Welcome everybody. In this tutorial series, I'm going to show you how to code in Python in 1 hour. That's right. I'm going to show you how to code in Python in 1 hour. And this is going to be a fantastic tutorial for anyone who's never coded before. So if you've always wanted to code and you've heard of Python, or even if you haven't heard of Python and you want to learn to code, this is the place to start. I have a lot of 1 hour videos, and these 1 hour videos will show, or they show people how to code in 1 hour. So if you have an hour, a free hour here or there, you can go and take this course, and at the end of this course, you'll have a basic foundation for coding. And this is the best part about these 1 hour courses, is that I've had a lot of students. In fact, as of this tutorial, I've had 150,000 students worldwide take my courses. And if you and a lot of those students, they started in this 1 hour. They knew nothing about any kind of coding, and now they're making apps and publishing to the App Store. They're publishing to Google Play. They're making games, etc. So this is 1 hour, and if you have the time, I highly recommend that you take this course. Python is a very easy to code in language, and it's used pretty ubiquitously around the tech world. Learning to code in Python will definitely help you with your career if you are coming up for a review, or if you want to start a new career in coding. I hope to see you in the course. Welcome everybody. In this tutorial, we're going to be talking a little bit about what to expect in the course and what you need for the course to get it up and running. First things first is let's talk a little bit about the website that you're seeing right here. Well, the first thing is that you need to go to rextester.com, and it should bring you to run code. If it doesn't, you can just go and type that in. And what this is that this is going to allow us to run our Python scripts online, and it will allow us to check our work. Now there's a couple reasons why I like this. First reason is that when I do these tutorial series, sometimes I have to use software that is only for a specific system. For example, if you want to make iPhone apps, you need to use Xcode, and in order to use Xcode, you need to have a Mac. It's very hard to have it on a PC, but I get that a lot, and in this way, everyone can use it. So if you don't see it here, I'm also using Google Chrome. Google Chrome is pretty good here. And if you want to, we can go to Python. Okay. There's also a Python 3. Okay. It also works there. We'll be talking a little bit about that. And you can see it says this is the title of the code, Python, and then if I just go to regular Python, this is 2.78, and that is the version of Python. Now, let's talk a little bit about the format of this course. So this here is the video size, and for the most part, it's pretty big. Now, what I'm going to be doing is I'm going to be zooming in just by this here, and the way that this website is set up, I'm going to be doing a lot of scrolling like that. Now I zoom in so that everyone can see what I'm talking about, and when I zoom in like this, you may or may not see this 100% clearly. And the reason is that when you zoom in, sometimes it gets pixelated, sometimes it doesn't. So if you are seeing a bit of pixelation, that is just a physical limit on how pixels work. All right. Either way, that is what I'm going to be doing, is I'm going to be zooming in and out like that. Another thing that I want to talk about is the format of these courses here. Now I have at this tutorial here, Mammoth Interactive and myself have about 150,000 students, and I have got a lot of feedback on what works and what doesn't. And after being a teacher for many years, and after being a producer for many years, I do have a certain style, and that style is short tutorials. And there's a ton of reasons why this is really good. First of all, most people like the short tutorials. Not everybody does, but most people, and by most I mean probably 95%, 90 to 95% of my student base. And what that means is that you have a short tutorial. It does a very much what I'm supposed to talk about, and nothing more. So when you go back to the course 6 months, a year later, you can find the lecture title, and you can find out what you need to learn. This is better than having one big hour-long segment and you have to kind of flip through video. So I definitely like that. Also, I find that students get through more of the course if they go and have short tutorials. Okay, so keep in mind that a lot of my student base likes those short tutorials, and that's the way it's going to be. Okay, so here we go. We pretty much have this set up here, and let's talk a little bit about Python in the next tutorial. Welcome back. Okay, so let's take a look at a little bit of Python here. And by the way, this Rex Texter, you can see that there's all these really cool different kind of languages that you can look at here. But let's take a look at, we got Python 3 and we have Python, okay? And you can see that they're slightly a little bit different here. And the way that Rex Texter works is that you run the code and then you simply run it here, and you can see that it is hello world, okay? And if we go to Python 3, you can run it, and you can also see that there is hello world as well. So the question is what is Python used for? Well, Python is used for a ton of different kinds of environments. It's extremely versatile. And one thing that that you use Python for is anything from graphic user interface, from GUI, to cross-platform apps. So if you want to make something for PC and Mac, you can also use it. It's used a lot in 3D environments. So if you wanted to make, let's say, some kind of 3D program like a game or something that edits 3D materials, Python can be used for that. It's extremely versatile. And the other thing about Python is that it's fairly easy to use. And what do I mean by that? Well, if you go into older programming languages derive their lexicon or their word choice from math and physics, or mostly math though. So if you had a math degree, you would find a lot of the concepts to be second nature to you. However, most people's math skills aren't that advanced, and as time has been going forward, programming languages have been getting easier to use for the common person. And so, again, computers were originally to do exactly that. They were to use computation. They were to solve mathematical problems. You can probably remember that the first Apollo the Apollo missions going to the moon had a calculator the size of an oven or a microwave, big microwave that is. And nowadays you can get them fairly small. But the point is that computers were supposed to use mathematical concepts. So Python is something that is easier to use and it's easier to understand. You can do your work much more easily. Okay, so we're going to be moving on and we're going to be getting into code in the next tutorial. Welcome back. Okay, so let's take a look at how we can go and look at how Python works. Okay, so you see that there is a couple of items at the top here. There's a little number sign. It says title of this code, and then Python, etc. Also, there's a print here, and it says hello world. We run it. It says hello world. You can go ahead and you can print out your name here, or it can print something fun like this, and it can go ahead and run it there. It prints anything that you see within these quotes here. And this is something that you need to know about programming languages in general. When you print something, generally it is within these quotes here. And these quotes print something called a string. Now, a string in computer language is characters. They're different from numbers. They're characters, like the word you see here. And we can print whatever we want here. Okay? We can also do the exact same thing on the next line. We can go to print, and then we can say something like 2 quotes in here, and we can say is super awesome. Okay, something like that. And then if we go and run it, you can say that they're all in different lines here. And we could copy and paste this, as many times as we want here. But, we can do that here, and we run it here. And you can see that there's a bit of an issue because I put that on the different line here. And you can see that it does simply work. So this highlights something on how computer programs work. The way that you make a computer program is you tell it to do something. In this case, we told it to print. You could tell it to tell the time, or you could tell it to calculate the distance in between 2 points on a geographic map or something like that. But in this case, we just told it to print. And the compiler reads it line by line. So it reads this line, and then it reads this line, and then in this case, it's finished, right? So there we go. Now, if I happen to make a mistake, like if I, for example, forget the I in print, watch what happens. It says, uh-oh, there's a problem here. That means that you have to get your everything 100% correct. If you make a simple mistake like that, it won't work. Now, don't worry. Just because you make a simple mistake like that doesn't mean it's the end of the world. Okay? Most of the time, when you're programming, your issues end up being human error, meaning that you make a typo or you misplace some logic, etc. Okay? But in this case, you always want to make sure that you write down everything the way it's supposed to be. Okay? This includes a tutorial. Let's talk a little bit about something called variables. Now, variables are really important in terms of computers, but they're also important in terms of programming and the logic that we use it in. So, the way that I like to describe variables is a variable is something where it's a place where you can put a piece of data. You can put a number, you can put a string or a bunch of characters, or you could put in something called a Boolean, which is a true or false, kind of like a light switch. So how do we go and add in a variable? Well, it's actually really simple. We're going to say some number is equal to 9. Okay? So we got some number is equal to 9. Now, watch what happens when I type in some number here. Okay? And we go and run it, and you can see that it prints 9. Well, that's actually pretty cool. Let's get rid of this up at the top here, and let's just print the sum number. Okay, so we hop down, sum number is 9. Now I can change this to whatever I want. I can change it to 91. It's going to be 91 here. Now, what this means is that the name of this variable is sum number, and then it's equal to 91. Now, if I just put in some number like this, you see that it says that some number is not defined. And what that means is that you have to initialize a variable, which makes it, you have to make it equal to something. So some number is kind of like a box, right? It's a box you can put a number in. And we could call this anything we want. We can call this banana. We can call this apple. But it doesn't make sense to call our variables something that doesn't make any sense. So if you're writing, let's say, an app, or you're writing some code that deals with traffic, or let's say deals with car speed, you want to do variable names such as car speed. We'll make that equal to 100. You can say it's like car braking power, make that equal to 12, and we can do car steering, make that equal to 12, etc. So the other thing is that you notice how that I've gone ahead and I've said car speed, and the way that I wrote that out, it wasn't like car speed like this. It was car speed all one word. And the reason for that is that when you're declaring variables, you can't have spaces. Now, the old school thing to do is to have an underscore, which is totally fine. But what a lot of programmers do is they just don't capitalize the first word, but they capitalize the second one. Okay? And the reason is that you can see that just a little bit better when you capitalize it. So you see, you got car braking power, you can see exactly what that is. And you can clearly see what everything is. And we can print these for whatever we want to do. Okay, so that deals with number variables, and this is what we call an integer variable. And we'll talk a little bit about types of variables in the next tutorial. Welcome back. Okay, so let's take a look at different variable types here. So in this case, we have car speed, we have car braking power. We can actually do this, for example, sum int, we'll make that equal to 12. We'll call this sum float, and we'll make that equal to 22.3. And we'll also have sum long, and we'll make that equal to negative 0.23. Let's take a look at this here. Now, what these are is that these are different kinds of variables. An integer is a positive or negative whole number. A float is a positive negative with a decimal point. Okay, so you can have an integer with a decimal point. Now, what's kind of interesting about Python is that you don't have to describe the kind of variable that you're using. Now, if you've ever taken C++ or any kind of other programming language that's a little bit older, or even one that's specific to a certain device, such as iPhone or Android, etc., you'll note that you have to declare the type of variable. So, just making this up here, if I said, this is an int, like that, you'd have to declare that this variable is some kind of int. In Python, you don't have to do that. You just kind of let it go like that. Now, what's interesting about this is that we have some int, some float, and some long. We also could have some string, and then we make that equal to, awesome here. And what that does is that is a character here. Okay, so there are different kinds of variables, and you want to make sure that you know which ones are what. This concludes the tutorial. Welcome back. All right, so can we do math with this? Can we add these all together? Well, let's try that here. Let's add all the number variables first. We'll do sum int plus sum float plus sum long. Okay, let's hop back in and let's run it, and you can see that we can do this here. Now, this is actually really important, and it's really important because in other programming languages you cannot mix integers and floats and longs. You have to declare integers with integers. Okay, and that's something that's really important to know, so that it makes life a lot easier in a lot of ways. So if you want to, let's say, mix a bunch of numbers, you can go and do that here. And you'll notice what this does is that this does the math for you. Okay, it doesn't print 12, 22.3, and then 0.3 all together. It actually does the math for you. We can also do something like sum math is equal to sum int plus sum float. And it is case sensitive here. So if I did sum float like this with the, let's see, just to make it more, if I did that and capitalize the word float, it would not work. So sum float plus sum long, okay? If I did that here, and then what I would do is I would say, instead of printing all this, I'd go sum math, like this, and run it. You see it's the same number here. So you can do math like that as well. But what happens if you want to, let's say, do sum string? So I'm going to add that here. What happens here? It says, uh-oh, there's a bit of a problem. Well, what we have to do is we have to do sum string, and then if we run it here, you can see that it does work. So you can add the strings like you would in JavaScript. In JavaScript, you can do that. You can't do that here. If you want to add in a string, you can simply do the comma there, and that it works here. And that's the way that it works. When you think about it, strings are not the same as numbers. You can't, if you want to do 1 plus 1, that equals to 2, but you can't do 1 plus the letter J is equal to, I have no idea what that equal to. It just doesn't make any sense. It's like saying, can you pick me up? If you tell your friend, it's like, can we meet at this intersection? And then your friend just does something completely different, you know, just like kind of leaves the country or something like that. It doesn't make any sense. So that you want to make sure that your logic makes sense. And this is something that is a very basic principle of that you can't add numbers to letters. The only close thing would be if you were to add 1 plus j, it would be kind of 1j. But that still is kind of an approximation and is exactly the right logic. This includes a tutorial. Welcome back. Let's delete everything but SumString. Okay, and there's stuff you can do with strings with Python that's already built in. So a lot of programming languages already have a bunch of built-in functionality to to their compilers. So what I'm going to do is I'm just going to simply do times 2. Now that's exactly what it's going to do. It's going to print this twice. Now notice how there's no space in there. That's because there's no space at the end. If we do the space at the end, you can see that there is a space. Now, if I also do a space at the beginning, watch what happens. You can see that there's another space here. And I'm just going to add in a bunch of spaces. And you can see that there are indeed spaces here. Now, what this means is that everything that you print within the awesome is taken literally, meaning that if there's a space there, there is going to be a space at the end of it. Okay? And, you know, let's say if we want to do this times 4, you can see that it does indeed multiply it times 4. So that's pretty cool. There's a bunch of other things you can do here. So for example, you can do a plus, and you can do another string, and then we can do plus again, and we can say something like, you know, like that, and watch what happens. You can see it says awesome, another string, and then Mammoth Interactive. Now again, I didn't put the space at the end of that, so that we can go and run it, just like that here. Now what a lot of people do is they don't actually put spaces at the end. They use something like space string like this, and they'll make it equal to a string. So instead of having the spaces at the end, they actually add in space string. Okay? And then they add it in there. So I'm just going to space, or yeah, it's space string plus, and then what that's going to do is that that's going to add in the spaces here. Now we've set this to whatever we want here. We could set it to a number sign just to show you how that works, right? You know, it says another, etc. Okay. So that's what a lot of people do with the strings, etc. Now there's a few more things that we can do with the strings. If I just go ahead and I delete the rest of that, and we can say, for example, we could print the first character. Okay? And how do we do that? Well, let's do some string, and we're going to be talking a little bit about these square brackets. And let's say we do 0. Now, this is kind of a tricky concept here, but 0 you can see is the first character. Now, computers deal with something called zero-based counting, and zero-based counting starts at 0. So even though this looks like the first letter, it's actually in the computer's mind the 0th letter, the 0, and we call this an index. Now what we could also do is we could do 2. So we could go 0, 1, 2, and this should print an E. Okay, there we go. What you can also do is, for example, do 1, 3, and watch what happens. Okay, it prints the 1 and the 3. Right, very cool stuff. And then if you wanted to just simply do, for example, 3 and a colon, it says go 0, 1, 2, 3. It starts printing 3 and goes on the end. So if we wanted to do 1, it would just go just like that here. Okay? So those are some cool things you can do with strings. This includes a tutorial. Welcome back. Okay, in this tutorial, we're going to be talking about lists. Now, in Python, they're called lists, but in other areas of programming, they're called arrays. Now, you see that we have a variable here, which is called SumString, and that SumString is equal to awesome. This is, a variable is like one you can put one piece of data into it. A list, you can put multiple pieces of data. You see how there's these square brackets here? We're going to talk about what those square brackets mean, okay? So we're going to say sum list, and we're going to make that equal to, and we're going to put the square brackets here, and we can say we can add in an index or an item to this list, okay? And what we're going to do is we're going to actually use the single quotes here, and we're going to say, for example, mammoth, and then I'm going to put a comma, then I'm going to put in two more. I'm going to say interactive, comma, two quotes, is, comma, two quotes, amazing. And then, you know what, just for fun, we'll put in an exclamation point in there, okay? So SumList has exactly 1, 2, 3, 4, 5 items. And if we print SumList, and we just type in, SumList like this, and we run it, you see that it just essentially prints that there, okay? And this is what a list is. Now, this here is a list full of strings. You can have, for example, some number list. And can you have numbers in there? And you absolutely can. You can have 23, 34, negative. And they have to be separated by a comma, by the way. Let's see, negative 34, etc., etc. Okay? And if we put or print some number list, we go ahead and run it. All right? And I just want to, and you actually need the equal sign there as well, and that's why I got the error. And I can go and run that again, and then you can see that we have the numbers here. So you need the sum number list and the equal sign, etc. But the question is can you actually use both? Okay? Can you do both strings and numbers here? Let's try some other list. Make that equal to square brackets. And those square brackets will say, mammoth. And we'll say awesome. And we'll say 99. And just as a tip, by the way, if you double click your variable or list name or any kind of name that you need to print, you can copy it and paste it in there. That way you don't make a mistake. Okay? And you can see that they both work. And this is something that's interesting to Python. Some other programming languages do this, but generally you do not want to mix the strings and numbers. Most other programming languages don't allow you to do this, but in Python they do allow you to do this. So it's possible to do this. However, it's better if you don't. Okay. The reason is that it could get confusing. The one major reason that you can do this is that, for example, let's say you made a game or something like that, and the game had a bunch of for example, it was a spaceship, and the spaceship had a name, it has like a strength, shields, hit points, etc. Well, you could, in theory, use a list for that if you really wanted to, okay? So, that's lists. We'll be talking a little bit more about this in the next tutorial. See you then. Welcome back. Alright, so the next thing we're going to do is we're going to take a look at how we can go and print this list. So, we have printed a list. Let's go back, and I'm actually just going to delete these two because we're just going to deal with some list. And if you really want to, we could add in a number at the end just to show you that it does indeed work here. So let's do some list, and we can go and print that, and you can see that it prints it. Now, what's interesting about this is that it prints the brackets as well. And if I didn't mention this in the last tutorial, every time you see these square brackets, most often the time, is going to be dealing with an array or a list or a series of items. And this is pretty much true throughout all programming languages. So now we have some list, and let's go ahead and let's print a specific index. Let's print the 0 index. Run it, and it just says mammoth. Now, the reason for this is that in this list here, this list starts at the 0. Starts at 0 here. So this here is the 0 number 1, 2, 3, 4, and 5. So we got 1 will be interactive, and there we go. And then what happens if we count this up? We got 0, 1, 2, 3, 4, 5. And what happens if we push 6? Okay. Work it. It says error. Index out of range. Okay. And I love the errors in programming because they're so far from plain English. In any event, all this means is that you entered a number that is not in the array. It doesn't make any sense for it to work. So now that we have that sum list here, what else can we do with this array? Well, as usual, we could multiply it times 2, and we can run that. And you can see that it prints them both out. And it still prints the square brackets at the end of it. So there is that. We got sum list and times 2. And then the next thing we can do is you can actually do, you can add arrays together. So let's go ahead and let's go sum other list. And remember, you can have spaces in between there. So we'll go ahead and add in the square brackets, and we'll just put 99, 12. It doesn't really matter what it is. But let's just do plus some other list. And if you always want to copy and paste it, you're more than welcome to do that. We can go and you can see that it adds in both of them. I'm going to change this number here to 19 just so that you can kind of see that here. So you can see that it prints both the lists together. You can do this an unlimited amount of times. You can even go sum list here, okay? Because to the computer, it doesn't, you can add in all of these times as you want here. You can even, let's say, multiply it by 7. Let's take a look at that, and you can see that that's just a lot of arrays. So you can, so these concepts, most of the time in computer programming, the concepts are scalable, meaning that if you add one, you can do another here. And for example, adding makes sense because you're adding it, but what if you subtract it? Okay, obviously it says type error unsupported operand types for, you can't subtract a list, and you sure cannot divide a list. Okay, you definitely can't do that. So sometimes you need to be able to do that here. Now there's a couple other things we can do. We can go ahead and let's say we wanted to print the second to the fourth only. So that would be 1, 0, 1, 2, 3, 4. So it should say is amazing with that here. So we got 2, 3, and then 4 here. Okay, we can add in this as 5. You can see what happens. There we go. Okay, if you just go, for example, 2, and you don't put a second number in there, you can see that it prints the rest of the array, which is also kind of neat there. Okay, so those are all the kind of things you can do with the list or the array. And for the most part, you will use these quite a bit. In fact, you can make a lot of really awesome apps just with this kind of Python stuff here. This includes the tutorial. Let's take a look at some other things you can do with lists here. So first of all, we can go and say, for example, sumList.append. And then we can add in something to the end of this. Let's add in 100. So if we run it, you can see that now we have 100 at the end where we didn't have it before. And what we can also do is we can append as many items as we want. Of course, they have to be on different lines. And let's just change this to each one of these here so that we can actually see the list here. So you can see that we have 100, 101, 102, 103, and 104 here. So what this is that this highlights something that's really important. You have some list, and then you have in some kind of function that you can add into this. In this case, we appended, okay? And there's other functions we can use with this. And for example, one of the ones is insert. We could insert, so we just do simply dot insert. And we pick the index first. So let's say we want to put it at the beginning, and we'll remember 0 is completely at the beginning. And we can add in, something like insert, something like that. And that way we know that this is the insert here. Okay, and then of course we print the sum list. And then we go insert, and you see it's at 0 here. Now if I go ahead and I push it at index 2, you see we got 0, 1, 2. Now 2 is insert. Okay, we can go up to 5 or whatever, and you can see that it inserts it at 5. Okay, now of course we can insert it at the 5th one as many times as we want, so it will always insert at 5. Pretty cool stuff. Okay, so we have that here. We could also count the item. We can count how many times something is in an array. So let's actually put that back here. So let's say I go sumList.count, and then I actually put in insert here. We run it. You see it happens 4 times. And if I copy all this and paste it again, guess what? 8 times. But if I actually take a look at this here, and I say interactive, it's only 1 time, which is kind of neat. So you can also count. What you can also do, which is actually really cool, is you can go to sumList.reverse, just like that. And guess what? I'm just going to go ahead and delete this here, and we'll print the list. Okay, it reverses everything. Okay, so these are some of the things you can do with lists. This concludes the tutorial. Welcome back. In this tutorial, we're going to be talking about if statements. Now, if statements are one of the basic programming knowledge pieces that you need to know, and it's also one of those things about coding that you use, well, pretty much forever. I use if statements in commercial applications that I make today. And the best part is that if statements are really, really easy to understand. Okay? So let's take a look at if statement. First of all, let's add in some, let's call it some number here. We'll make it equal to 5. And we'll add in an if statement. Now, an if statement works like this. If condition and put a colon there, and then we'll say action. So some real world examples of if statements are: if it's raining outside, you can bring an umbrella. If it's snowing outside, wear some boots. If it's really sunny outside, wear some sunscreen. Or if it's cold outside, wear a jacket. Okay? Now, those are some real world examples, and this here is of course kind of plain English. It's not exactly the way it works. Let's take a look at how an if statement really works, and we'll say if some number is double equal to 5, colon, we'll go print, and we'll say something like awesome. Okay? So we run this here, and it does indeed work. Okay? Now, let's go through the anatomy of the if statement here. So the if statement has the if, we have the condition, which is this highlighted area, and you also need a colon at the end. If you don't have a colon, it doesn't work. So put the colon in there. And you'll also notice that there's a double equal. If we do not put this one equal sign in there, if you put one equal sign, it won't work. You need the double equals. Why do you need the double equals? Well, that's just the way if statements are. Okay? Now we can have an unlimited amount of these here. So for example, if I have another if statement and I say, we'll call this some other number and make that equal to 6, and we make if some other number is equal to 6, we'll say great. So if we run this here, it says awesome and great. But what happens if we say if some number is equal to 6? Okay, right now some number is equal to 5, but in the if statement is running it and says some number is equal to 6. Let's go ahead and run that. You notice that it doesn't print. Well, that's because the condition is not true. And if the condition is not true, the if statement isn't going to run. So the condition has to be true. Okay, so we have if some number is equal to 6, print awesome. If it's not equal to 6, then we do not do anything here. Now, when we're going through logic and if statements, we need to make sure that when we're going through it, that you read the code like a computer, meaning that you read the code line by line, and the computer compiles this line by line. So you're never going to see in this example great printed before awesome, because that's impossible. Great is printed after the if statement, and therefore it will be always printed in the result after this awesome here. Okay, so that's a basic part, or something to show you how if statements work. This concludes the tutorial. In these if statements, we can actually use a bunch of math, and these are kind of math logic, and we use these quite a bit. So what I'm going to do is I'm going to say, turn this back to 5 here, and I'm going to get rid of this if statement here. So we're just going to deal with one if statement, and we're going to say if some number is greater than 5. So let's say it's greater than 4. So if some number is greater than 4, we print awesome. We run it, it indeed works. If we put it to 5, is some number greater than 5? It is not greater than 5. So we can also say, is it less than 5? Or we can say less than 6. So if some number is less than 6, we indeed print that there. So you see that we can have greater than or less than. Now, why would we ever need this? Well, for example, if you're making a game and your lives are less than 0, then you kind of restart the level or something like that. There's lots of places you can use this. But in addition to the greater than and less than, you also have greater than or equal to. Okay, so if we have less than or equal to 6, okay, so let's actually put this back down to 5. So if it's less than or equal to 5, then it still works. But if I say is less than or equal to 4, it doesn't work, because of course some number is equal to 5. Likewise, we can do the same thing with the greater than. So if it's greater than or equal to 5, or it's greater than or equal to 4, okay, and there we go, it does indeed work. Okay, so we have those two math equations there. We also have the equals, which we've already worked with. So right now we have a total of 5. There's one more, which is does not equal. Let's say it does not equal 4. Okay, some number is equal to 5, and there we go. It does not equal. So you add the exclamation point there. And that's pretty much all you need to know at this point in time for those math. This concludes the tutorial. We can add in some more functionality to this here. So we have if, and we can also have an else. Okay, and the else works with a colon there, and we can say print, and we'll just say something like else. Okay, so if some number, let's just say if some number is equal to 4, let's run it here, and we'll say the else statement. Okay, so let's walk through the logic of this else statement. So again, as a computer, you read the code line by line, and it says if some number is equal to 4, then it prints awesome. In this case, some number is not equal to 4. Okay, we only have some number, which is 5. And then once this if statement is not true, so this highlighted area is the if statement, this else means that if this is not true, then we do whatever's in the else statement. Okay, in this case, we run it, and it says else. Okay, and we can do this with all the other types of math here. So for example, if some number does not equal 4, is that true? Well, it doesn't equal 4. Some number is equal to 5, and so that's true. But if I change this to 5, okay, you can see that the else statement gets fired there. So we can have an if statement, and we can have an else statement as well. Now, what this means is that another thing that you need to know with if statements is that for each if statement, you can have an if and an else. And we're going to be talking about in the next tutorial about, for the most part, an else if statement. But you can have an unlimited amount of these, okay? But you can't have two else's to an if statement. So let me go ahead and put another else here, and we'll say something like fun. Okay, run that here, and you can see that it says that it is invalid. The reason is that you can't have two else statements. It doesn't make sense logically. All right, this concludes the tutorial. The next thing we need to talk about is an else if statement. So what an else if statement is the way that we do that, it is if. It's what it is it's kind of an abbreviation of else if. And if you've coded in any other programming language, you usually write else if like this. But we can just simply do that. Okay. The next thing we need to do is that else ifs also have a condition to them. So we'll say some number is double equal to 6. Okay. You need the colon in there, and of course we'll say print. We'll say something like elif, like that, and we'll make sure that we put this in here. Okay, so let's say 6 here, and we'll say that is equal to 5. So let's run that here, and you can see that elif works. So the way, again, that this works is pretty simple. The computer reads the code line by line, and it says if some number is equal to 5, it prints awesome. In this case, this is not true. So it hops down to the next part of the if statement, which is this else if here. And this else if is some number is double equal to 6, and that is true, so it prints it. Now, if this is also not true, then anything else goes to the else. Okay? So the major question is how can you or how many else statements can you have? Well, you can have as many as you want, really. You can have 10, 20, 30, 40, 50 of them if you want to. But for the most part, let's just take a look at this example where I just simply copied and pasted and I run it here. And now, while it technically works, this is a human error because you shouldn't have two else if statements that are different. If we put something different in here, let's see, take a look here, right? It just runs the else because it doesn't actually get to this code. So you want to make sure that that you do indeed make sure that your logic is correct, because oftentimes when you are making code and writing code, the code that you're writing will have errors that you put in there that are logic errors and not compiler errors. Okay, so you can see this that you have this here. Now another thing is what do you use ifs and else if statements? What's the best practice for this? Well, generally when you have an if statement, you want to be using ifs and else ifs, and for the else is kind of like a throwaway that if something weird happens that you put in there. Okay, so for example, you know, it's like, let's say you're making a simple app that deals with money, right? So if the price, let's change this to price actually, if the price, and I'll just kind of do this here, if the price is double equal to 50, then you can say it's like you have enough. If it is, for example, greater than or equal to, or if it's greater than 50, you say you have more than the amount. Just like that. So you have enough, you have more than the amount, and then if you say something like if you have less than 50, then you can say something along the lines of you do not have enough money. Okay? So this makes sense. And then the else if statement says is, you know, you can say something like error. It's something that's different. That's something that, you know, you haven't really accounted for. So like this happens all the time in computing, and it can happen when, you know, for some reason something happens in the back end that messes up your app. So having this little fail-safe is important. Also, your error message, if it just says error, is a little bit vague, you never want to be vague with your errors. You say you can say something like, well, does not compute, which would actually work here. But you say error. You can say whatever the error might be. You might even have a bunch of else ifs dealing with an error here, but you generally don't want to be as vague as you can here. This is such a simple. It's like, for example, error not enough data. Okay, you always want to make sure that your errors are very clear. And also, if you want to put in like an error code like 4025, that's pretty common too. But don't just put error 4025, not enough data, it says like insufficient funds. Those are much better error messages than just error and then a number. This concludes the tutorial. There's a few more things we need to talk about with if statements. First things first is we need to talk about multiple condition if statements here. Okay, so I'm just going to add in a bunch of generic variables here. We're just going to say 1, 2, and then 3. I know it's pretty generic, but it's a really good way to make this work here. So if this if statement works, so for example, if a is double equal to 1, and what happens if you want to check for multiple variables? So in this case, we type in and b is double equal to 2, and c is double equal to 3. Okay, run it, and you see that it all works here. But if I change one of these up here, so for example, c is equal to 2, doesn't work. We can also put in an else statement, and we can say something like print a, b, or c is not correct. And if we run that here, it should say a, b, or c is not correct. And that's pretty standard here. So what this means is that when you use the and one thing I absolutely love about Python is they actually use the word and. In other programming languages, they use a symbol. And why use a symbol when you can just use the word and? So what that means is that all three of these conditions have to be true. And if one of them is not equal to true, or is not true, then it won't work. Okay? Now, how many of these can you have? In this example, we have 3. Could you have 5, 10, 20? You can have as many as you want. In fact, lots of times when you do use an if statement in more complex applications, it's to check for some really random event. So let's say you're making an app and it crashes with this one really obscure happenstance. In fact, one of my friends who's making a game said for whatever reason when the helicopter spawned in this certain location it crashed and no one could figure it out. So you add this if statement with maybe 10 different conditions saying that if the helicopter was spawned at this time in this place, etc., 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 then spawn it somewhere else is really what it came down to. So in if statements, it's usually something that's really, at least when you use it in higher higher applications, it's something to check something really obscure. And the other thing is that when you're doing these tutorials here don't really show you what it's like to actually once you're in the thick of code. And you just have to remember that if you have 10 conditions, that's totally fine. All right, this concludes the tutorial. Welcome back. Okay, we have and, we can also do or. So you can have a multiple condition if statement, but there could be ands or ors. Okay, now we have to, what that means is that if one of these is correct, but the other two are false, then it will still work. So we have to change this here. We'll say none of the variables were correct, and that makes perfect sense. But if we run this here, it'll just say awesome. But if I change, 2 of these to 9, but c is equal to 3, it will still work. Okay. The reason is that if the way that works is that either this or this or this is equal to true, then it's going to print. But if all of them are equal to false, okay, it says none of the variables were correct. So if all of them are equal to false, it will then fire off here. Now, of course, can you use these multiple conditions in an else statement? The answer is absolutely yeah. You can absolutely do that. You can run it in an else statement. You can run it in an if statement, or an else if statement, not an else statement, but an else if statement, right? And you can have as many else if statements as you want. All right, this concludes the tutorial. Welcome back, everybody. All right, this concludes the tutorial. Now, I hope you've learned a lot about Python, and I hope that you've learned that coding, while it may seem hard on the surface, is that once you get into everything, it's not as hard. And I can say that as a programmer, it's always hard at first, but the more you code, the better you get. And if you go to my website, mammothinteractive.com, you can sign up for a free course to teach you how to code as well. So in addition, you can take that in here. And if you want, you can email me at johnburra@mammothinteractive.com. If you want a special deal on any one of my courses, just make sure that you say which course, and then I can usually try and find a way for you to get that course. All right. So going forward, what do you need to do? Well, if you want to get good at coding, I would suggest coding as much as possible. Even if there is no real goal in the immediate future, as long as you start coding and doing more of it, the better you'll get. A lot of the courses I like to teach it with Mammoth Interactive is that I like to teach people that to do small projects, and those small projects equal bigger projects, and a bunch of small projects will make you a very good coder. All right. So once again, I thank you for taking this course, and I hope to see you in another course. Thanks again.